Given f of x equals x squared, sketch g of x equals negative 2f of x minus 3 plus 1. First, I'm going to sketch f of x equals x squared. That'll help me visualize the parabola, and it will also help me generate some points. We know from sketching a parabola that we have a vertex at 0, 0. We go over 1, up 1, over 2, up 4, over 3, up 9. So however far over we go, we square that number. And I'm going to label that f of x since I'm leaving it on my graph. And I'm going to use my data points here. So negative 3 and 9, I'm going to list my data points from f of x here. So I have negative 3, 9, negative 2, 4, negative 1, 1. My vertex was 0, 0, 1, 1, 2, 4, and 3 and 9. Okay. Then I'm going to apply the stretches and reflection first. So I have a reflection over the x-axis. So I know I can visualize that happening and multiply it by 2. But since I've got a table here, okay, this method will work if we have our table for every kind of graph. I'm going to use mapping notation and apply my stretches and reflections. There was no horizontal stretch. I will then move the graph afterwards. I'll have to move it right 3 and up 1. Okay, so nothing happens to the x-coordinate, so I like to just list that again. The y-coordinate, I'm multiplying by negative 2. And notice the numbers are repeating themselves a little bit here. Okay, so I'm going to plot that. I should recognize that this is going to be down here now, and it's going to be stretched vertically, which means it's going to appear narrower. So negative 3 and negative 18 is off my page. I don't necessarily need to plot that point. That's okay. So I'll start with negative 2 and negative 8, negative 1, negative 2, 0, 0, 1, 2, 2, 8. Keep in mind, and I'm just going to do this as a dashed line, as just sort of showing my work here. Keep in mind, we're used to parabolas and often talking about the width by a factor of 2. Normally we'd go over 1, down 2, over 2, down 8. So we can see that that confirms what we already know and the reflection. Now I need to move this right 3 and up 1. So I'm going to use my final answer. I'll make this a little bit darker here. So 1, 2, 3, right, up 1. I can move each point, or I can just keep that general shape of over 1, down 2, over 2, down 8. And the same thing would be symmetrical on this side. So this is my final answer. If you look at the question again, the final answer was called g of x with these transformations. So I'm going to label my final graph g of x.